Hey guys, this is CHEMPLIFIED and today we will talk about Boyle's Law. In the previous video we talked about gas laws, in which we also discussed Boyle's Law to some extent. But today we will separately discuss Boyle's Law. So let's start with the statement. The statement of Boyle's Law is, for a fixed amount of gas, I repeat, for a fixed amount of gas at constant temperature, pressure is inversely proportional to volume. That is, P is inversely proportional to volume, or P is directly proportional to 1 upon volume. This is the relation, and we will further look into the relation and let's see how Boyle's law will lead us to some certain equations. Now this was our relation. V is directly proportional to 1 upon P, or V is inversely proportional to P, or we can also write it as P inversely proportional to volume, as we have written in the statement, but these two are same, one and the same. So we will use this equation for the derivation part. It's a really small derivation. V is inversely proportional to pressure. You can write this as V is equals to K 1 by P, where K is a proportionality constant, right? V is equals to K1 by P, where K is a proportionality constant. Now by interchanging the pressure from right side to the left side, you will get PV is equals to K, or you can also write it as constant. That is, the value of product of pressure and volume is constant. We can also write the statement as the second statement for Boyle's law, and it states that at constant temperature, product of pressure and volume of a given mass of gas is constant. This is nothing but the derivation that you derived previously. PV is equals to K, K is constant, and this is known as Boyle's constant. So if somebody is asking to find the Boyle's constant, he or she is simply asking you to find the product of pressure and volume. Boyle's law also gives us an important formula, that is P1 V1 is equals to P2 V2, and the condition is at constant temperature. This is a really important formula, and many questions are done by using this formula, or solved by using this formula. It states that product of P1 V1. What are P1 and V1? P1 and V1 are the pressure. For example, this is a box. Pressure is P1 and volume is V1. And second condition is, this box is smaller, pressure is P2, volume is V2. Now since pressure and volume are inversely proportional, as the pressure increases, as the pressure is increasing, volume will decrease, right? Pressure increases, volume decreases, or volume decreases means pressure is increasing. If pressure is decreasing, then volume will increase, right? This is a simple condition. Now look carefully. In one condition, you have a given pressure and volume. Those are P1 and V1. Then you increased the pressure. Pressure increased. Increased pressure, it means volume decreased. If pressure is increasing, volume will definitely decrease. Both of these are kind of opposite, so their value will always remain constant. Just to understand, consider P1 is 2 and V1 is 3. You will get 6, right? Now, if you increase pressure by 1, P2 will be 3. Then according to the proportionality, that is P is inversely proportional to volume, the volume will be 2 and the answer will be 6. So their value will remain same at constant temperature. The temperature should always remain constant. Then always P1 V1 will be equal to P2 V2. This is the formula which you will use to solve many different problems. Now we will take a look at the graph which are related to Boyle's law. The first graph is the graph between pressure and volume, that is pressure versus volume graph. Now if pressure increases, volume decreases, by the law, Boyle's law is pressure is inversely proportional to volume or volume is inversely proportional to pressure. You can use any one of them. So if pressure increases, volume decreases. If pressure decreases, volume increases. Simple. It simply means when pressure is at the highest point, volume will be at the lowest point. And when volume is highest, pressure will be lowest. It is as simple as that. Now we will draw the graph and you will find that the graph is like this. After looking at the graph, you can see when pressure is highest, at this point pressure is highest. Look at the volume. The volume is lowest. Right? Now, volume is lowest at this point. Volume is lowest. Pressure lowest, pressure highest, volume lowest is at this point. Look at the pressure. Sorry, volume highest is at this point. Volume is highest. Look at the pressure at this point. Lowest. There is one more change. Here you will write volume. So when pressure is highest, volume is lowest. When volume is highest, pressure is lowest. This is the first graph from Boyle's law, and that is between pressure versus volume. Right? The graph is known as pressure versus volume graph. Now we will move to the next. Now the second graph of Boyle's law is pressure versus 1 by V. Now from where we are getting this graph? We have to take use of ideal gas equation. Let the ideal gas equation is PV is equals to nRT. Let the number of moles be 1 mole. We are taking 1 mole of gas, right? So we can write PV is equals to RT. Now interchanging the position, P is equals to 1 by V RT. Right? Now in Boyle's law, temperature is constant. Right? R is Rydberg's constant, again a constant. These two values are constant. The only two variables are pressure and volume. Let RT equal to K, a constant. So we can write this equation as P is equals to K by V. From there we are going to find the graph. Now this equation is very much similar to the equation of line. Or you can write this as P is equals to K 1 by V. Now this equation is very much similar to y is equals to mx plus c. This is the equation of straight line from mathematics. You can take it from mathematics. Y is equals to mx plus c. Here y is equals to p, m is equals to k, x is equals to 1 by v. Now what is the value of C? There is no C, so C is equals to 0. C is known as intercept. Intercept means from where the graph will start. So in this case, since C is equals to 0, the graph will start from the origin, that is 0 0, and the graph will be a straight line because this is the equation of a straight line. The graph will be like this. These are two different temperatures, T1 and T2. At T1 the graph will be like this, at T2 the graph will be like this, where T1 is greater than T2. As temperature increases, the slope increases or the angle increases. Alright, this is the second graph. Now we will find the relation between density and pressure by using Boyle's law. So let's start. Now Boyle's law states that PV is equals to K. Right? This is the Boyle's law. This is Boyle's constant. Now density is equals to mass upon volume. Density is equals to mass upon volume. Volume is equals to mass upon density. Now put the value of volume in that equation, first equation. You will get pressure into m by d is equals to K. Now interchange the positions. You will get P m by K is equals to D, or just reverse the equation. D is equals to m by K into P. Now this is a constant, you know that, but there is something else, mass of a given body is always constant, right? So there are two constants in front of us. One second, let's move the page a little bit. Now both of these values are constant, so when a constant will divide a constant multiplied with a constant will give you a constant. So m by K will ultimately gives you another constant K1, or you can write K dash, right? We will write K1. You will get D is equals to K1P. After removing the constant and applying the proportionality sign, you will get density is directly proportional to pressure. That's what we do now. D, if we write density is directly proportional to pressure, and after removing the proportionality you will write density is equals to Kp. We first find this value and then we reach to this value. So we find the relation that density is directly proportional to pressure. This particular relation is the significance of Boyle's law. At high altitudes pressure is low. At high altitudes pressure is low, which simply means density is low. Density of air is low means, for example, in a particular volume on the ground, volume of oxygen is this, but at high altitudes the volume will increase and density will decrease. So there is less oxygen available in the same amount. Understood? Let me repeat again. At high altitudes pressure is low. At the top of the mountain pressure is low, which means density is low. At low density The gases expand, that means the particles are far away, and that's why oxygen level is low at high altitude. Understood? So the relation between density and pressure is density is directly proportional to pressure. This will be it for today's video. Thank you very much. In the next video, we will go for Charles' law.